In this course, we will build an AI that can answer questions based on a lot of data that we gave it. For example, a user asks a question and the AI is going to scan through thousands of pages, for example, of text that we gave it, and it's going to retrieve relevant information and answer the question accordingly. Here we will just learn the basic concepts and basics of this technology, and we will build full products in a different course. I will presume you completed the introductory course and you, for example, understand what pip install is. If you don't, please refer to the introductory course. The link to this Colab notebook will be just below the video, so you can work together with me and learn. First, we will install OpenAI. We will use OpenAI to convert text to numbers, to embeddings, because AI can only work with numbers, so we need to convert text to numbers. Then we will install Pinecone client. We will use this to store those numbers, that data, into this database. This is a database. Then we will install Pinecone datasets. This is so we don't need to go ahead and collect our own data. We will just use data from this Pinecone datasets libraries, so we have it a bit easier. And then TQDM is just for showing progress bars, so we can visualize data processing while we are coding this, and it only works while we are coding this. So we are building a knowledge base. Knowledge base is basically a database of information that we store for our large language model, so it can refer and read through that database and find relevant answers. Our data will be stored as dense vector embeddings. These can be thought of as numerical representations of the meaning behind our sentences, or words, or letters, or whatever. So we will basically convert text, the semantic meaning of the text, into numbers and store it into our database. There are many ways to get these embeddings from text. We can use open source models like sentence transformers, etc. But we will, for now, use OpenAI's ADA002 model to convert text to numbers or to dense vectors. So we will click this play button to install all of these libraries. Then we will go down and click this play button, and let me explain what this code does. First, we will import a load dataset function from Pinecone datasets. Then we will load dataset. We're going to use this specific pre-made, this is already existing dataset of vector embeddings that we will use, and we will put it into this variable dataset. And I'm going to go ahead and Control X to cut these few rows, and I'm going to just say dataset.head to show you what the dataset looks like. So as it's loading, we have a column ID and then IDs of the dataset. We have values. These are vector embeddings. These are our words, sentences, text converted to numbers. And then we have some sparse values, metadata, blob, etc. So we're going to do some data processing now. I'm going to return these few lines of code. So first, we're going to go ahead and remove or drop this metadata column right here because it has all values at none. Then we're going to rename this blob column into metadata. So if I execute this again, and we're going to wait for a few moments for this to execute. And now you can see our column where it was metadata with all none values is removed, and our blob is renamed to metadata. Next, we are going to put our data into the Pinecone database so we can retrieve it quickly. So we are going to go into pinecone.io and make an account. Then you will come here to API keys, and you will click this to copy your API key, and you will paste it right here where it says API key equals to, you're going to paste it here, and you're going to paste it here. You will also copy this environment, and you will paste it here, and you will paste it here. Make sure that you don't have any indices here if you are on a free Pinecone account, because you can only have one. And then we are going to say pinecone.init, and then we're going to pass in API key and environment. So we are going to initialize the Pinecone client. And then we're going to say pinecone.whoami. We're going to call this function to see information about this Pinecone client. And as you can see, it responded with username, user label, project name, etc. Next, we're going to be defining index name, because we are going to be creating a new index where we will store our data. This is like a table or a database for our data. And this is the index name that I defined. You can change it to whatever you want. Then we are going to create this new index. So first we're going to check if an index with this name already exists. We're going to check it using if index name not in pinecone.list indexes. So we're going to list all indexes, and if this name does not exist, then we're going to create one. So we're going to use syntax pinecone.createIndex, and the parameters we will pass are index name, dimension 1536. This is the dimension of OpenAI text embeddings ADA 002 model. This means that each vector is going to have this many numbers. And then we are going to say metric is equal to cosine. Now each of these vectors is going to be representing the piece of text that we give it. We can give it one letter, one word, one sentence, a whole book, it doesn't matter. But it's going to represent the semantic meaning behind this text. So if we give it the whole book, it's going to be very hard for it to guess semantic meaning in just a few these vectors. But if we give it one letter, we're not really going to save any semantic meaning. So we're going to give it maybe one paragraph of text, and it's going to be able to convert this paragraph of text into a number that's going to represent its kind of semantic meaning and what that paragraph means. After that, we are going to connect to the index that we just created using pinecone.grpc index command. We're going to pass in the index name that we want to connect to, and it's going to return connection, and we will assign that connection to this index variable. So this index variable is our connection to the Pinecone index that we just created. And after that, we want to just print index.describe index stats. We're going to just see the stats that this index has. So dimensions, index fullness, 0, namespaces, and then total vector count is 0. And now what we will do is we will insert some data into our database. So total vector count is not 0. So we're going to go through our database or dataset documents, and we are going to go in batches of 100 documents at a time. And we're going to say index.upsert batch. So we are going to upsert or insert, in this case, batches into the index. If you go ahead and reload this page in Pinecone console, you are going to see that your vectors are getting inserted. When you get a green tick mark right here, it means the execution finished with no errors. And you can also check that we have all of the vectors inserted. You might even have more because I need to reload the page for it to fully update. And now we have all of the data in our database, and now we are ready to search. Let's see real quick. We have how many vectors? It's going to show in a quick moment here. 38,000 vectors. So first what we need to do is we want to click here to get our OpenAI API key, and then it's going to go to this platform, to this link, and then you're going to just create a new key, and then you're going to copy it, and you will paste it here and here. So the way we are going to retrieve information based on our questions is we are also going to encode our question into these vectors. And then our database is going to perform a search where it will basically take the numbers, the dense vector value of our question, and compare it to vectors of our text paragraphs, and it's going to find the most similar text paragraphs and return those most similar text paragraphs to us. It's going to find them based on the meaning, semantic meaning. To understand better how all of this works, please watch my introductory course. Don't forget to always press this play button. So after that, we are going to define our question in this query variable. Then we are going to call openai.embedding.create, and we're going to create an embedding using this syntax, and we're going to pass in the following parameters. Input is our query string. We're going to put it in square brackets because this input, this create function expects an array here. That's why we're putting it in square brackets. And the engine is going to be our embed model that we defined here. The response we get from this function is going to be stored in this res variable. Now this response doesn't only contain our embedding vector, it also contains date and a bunch of other stuff. So we need to just extract our embedding vector. So the way we're going to do that is we're going to access variable response, and then we're going to access this property data and the element with index 0 and the property embedding. This will return the embedding, and we will store that into xq variable. Now this xq variable is basically an embedding of semantic meaning of this question, and we are going to compare this embedding of this semantic meaning to all of the other embeddings, and we're going to find the text which has the most similar semantic meaning. We're going to use this function to do that, so index.query. We're going to pass in our embedding. We're going to say return two most similar embeddings with similar semantic meaning. We're going to include metadata, and we're going to store the response into this res variable. And now I will go ahead and print this res variable to see what it contains. So as you can see, it contains 1 and 2 text embeddings. These are the most similar to our question, and now we can use this text to answer the question. And as the following step, we are going to put everything into one single function. Don't be scared, we already know all of this. We're just going to put it together, and we're going to finish our project. So what we will do now is we will simply send our question to GPT, and we will also send this text that we retrieved from the database, and GPT model is going to look at our question and the text, and it's going to formulate an answer to our question looking at the text, and it's going to return it to us. So this is the entire code here. Let's go through it. First, this limit is the limit of our prompt that we will send to GPT. We don't want to send the entire book of prompt. We want to limit the prompt to this amount of characters. Then we will define this retrieve function. This will put our question and our data text information into a single prompt that we will send to GPT and get the answer. So the retrieve function is going to receive a query, which is our question that we are asking. Then it's going to convert that question into OpenAI embeddings, or OpenAI embedding, and we are going to access that embedding by using response data 0 embedding, as I showed earlier. Then we're going to retrieve relevant data from our database. So in this case, we are going to pass in the question vector embedding, and we're going to retrieve 3 most similar chunks of text from our database. We're going to include metadata. We're going to store that into variable response. And then, as I showed you, this text contains metadata, names, IDs, everything. We just want the text that I will show you here. So in this response, as you can see, we just want this text under the key text. We don't want any of this up here nonsense. So the way we're going to access that text, we're going to say x metadata text, and this is basically to go through each of these 3 data points and retrieve text for each of them. And now we're going to build the prompt for GPT. So prompt start is going to be answer the question based on the context below, and then context is going to, we're just going to say context, and then prompt end is going to be question, and then our query is our question, and then answer, and the GPT is going to just continue, finish the answer. Next, we are going to combine prompt start and prompt end and put our context in between, our text in between. So we're going to use this part of the function for that. So for each context, so for each chunk of the text, we're going to first check if the length of that is greater than the limit, and if it is greater than limit, we're just going to say, we're going to create a prompt that's going to be prompt start plus the context, but we're going to cut it off at limit length, and then we're going to say prompt end. And if it's not greater than the context limit, then we're just going to combine all of 3 into the prompt. And at the end, after we combined all of our 3 contexts, we're just going to return the entire prompt. So this is what our combined prompt is going to look like. It's going to say, answer the question based on the context below. It's going to say context, and then it's going to give this context, this text context, and this text context. These contexts will be cut off at the character limit if they are greater. Then it's going to say question, which training method should I use, etc. And then it's going to say answer. This is the prompt we will send to GPT, and it will return the completion or the answer. So if you want to see your combined prompt that you made, you can just come here and then uncomment this print prompt, and you're gonna execute this line of code, and it's going to give you your prompt that you are sending to GPT so you can see if it's good. But what I will do is, I don't need this for now, it's just clogging my output, so I'm gonna comment this for now, I'm gonna remove this, and I will execute this other cell, and now it has the prompt that we gave it, and now we're going to just complete Mega GPT completion with this prompt. And the answer to this is the answer to our question, which is actually very correct. Because our question was, which training method should I use for sentence transformers when I only have pairs of related sentences? And the answer is NLI with multiple negative ranking loss. So this is correct. And at the end, you can Pinecone delete to delete the index that you just created if you don't need it anymore. I hope you enjoyed this course. If you have any questions, leave them below this video, and see you in the next course.